Okay, Pradeep. Today we are going to discuss this 2017 June paper, the S1 paper. Right. Initially, if you start with the first question, Pradeep. Let's see what the first question asks. It's coming with the general statistics. Pradeep. Reina weighted the random sample of 50 carrots from her shop and record the weight in grams of the nearest gram for each carrot. The results are summarized below. So there were 5 carrots with a gap of 45 to 54. So initially, if you want to start this question, basically the first step is we need to make the class boundaries. If there's a gap between these two, you need to make the class boundaries. So we can start from that. 45.52, this is 54.5, and this is 54.5 to 59.5. This is 59.5 to 64.5, and this is 64.5 to 74.5 is the answer for that. Use the linear interpolation to find the median weight of these carrots. So initially, to find the linear interpolation, the first step is we need to make the cumulative frequency over here. I write the cumulative frequency for this. How to find the cumulative frequency is 5. Add this 5 to 10, it's 15. This 15 to 22 is 37. This 37 plus 13 is 50. Then we need to physically understand that what do you mean by this 5? What do you mean by this cumulative frequency 15? What do you mean by cumulative frequency 37 and so on? That means the first information to 50 information is in this category. 5th to 15th information is in this category. I'll just use the annotation row. Then here it's 15 to 37 is in this category and 37 to 50th is in this category. That's what you mean by this cumulative frequency over here. So initially start with the median definition. Median is equals to n divided by tooth data. N is 50 divided by 2, that is 25th data. Now check whether where the 25th data is. 25th data is in between where to where? It's in between 15 to 37th. You can understand that this 25th data is in between which two categories? 15 to 37. 15 to 37th. That means the median should be placed in between these two gaps. It's in between 59.5 to 64.5. Right. Then we use the linear interpolation method. This gap. How to get that gap? M minus 59.5 divided by this large gap. 64.5 minus 59.5. Do the same thing for the numerator. The short gap, 25 minus 15 divided by the large gap. 37 minus 15. Then if you work out with this, you get the answer. You can simply do it. 25 minus 15 divided by 37 minus 15. Divided by 37 minus 15. That answer . So this answer turned up to 61.77. Median is equals to 61.77. Obviously, yeah, that is practically fine with this range. Then estimate the mean weight of these carrots. To find the mean weight, initially we need to find summation of fx column. Summation of fx column, how do you make it? So you can make, this is the f column and x column is this. You can multiply these two. And you can make the sum of that column, because some of the cases they used to give us that information over here, but it's not there. Therefore, we need to make it. How do we find this fx here? 49.5 multiplied by 5. 49.5 multiplied by 5. That is 247. 247.5. Then 512. 70. It's 1364, then 69.5, sorry, 69.5 multiplied by 13. It is 903.5. Then if you add them together, summation of fx would be that is turned up to 3085. 3085, therefore mean is 3085 summation of fx divided by n number of information. There are totally 50 information over here. So the mean turn up into 61.7. 61.7 is the answer for that. Then the next part is find the standard deviation of this. So simply you can find the standard deviation. Straightforward, you can't find it. Initially, we need to find the variance. Variance is summation of fx squared divided by n minus summation of fx divided by n all things squared. The fx squared is 192.5 divided by 50 minus, this is summation of fx is 3085 divided by 50 whole thing squared. With this, you can get the variance, right? 192. That answer is 35.16. 35.16. Therefore, you can get the standard deviation is the square root of that answer, 35.16. So the standard deviation become 5.93. That's the answer for that, right? Okay. The carrot is selected random from the 9 shop. Estimate the probability that weight of a carrot is more than 70 grams per day. So you have to count the number of carrots more than 70 grams. Yeah. So over here, that is fall into this category. Now let's see how to find the number of carrots more than 70 grams. Now you can see 64.5 to 74.5. In that gap of 10, there are 13 carrots are there. In that gap of 10, there are 13 carrots are there, right? Because we need to make a proportion over here. Then we need to see whether the number of carrots more than 70 grams per day. Then see whether 70 to 74.5. What is that gap? That gap is 4.5. In that gap of 4.5, we need to see whether how many carrots are there, because you know that this 13 is distributed in this range equally. Under that approximation, we can say for a gap of 10, if there are 13 carrots are there, for a gap of 4.5, how many carrots we can expect? We can work out like this. You can use a cross multiplication is 13 into 4.5 divided by 10. Then x become 8 into 4.5 divided by 10 would be 5.85. Doesn't matter, you get a decimal answer because it's come with the probability, doesn't make a significant change. So the probability become 5.85 divided by 50. That value is 0.117 would be the final answer for this question. That's a way of doing this question, right? The box plot shown in time t minutes to take the group of office workers to travel to work, right? Find the range of the times. So the range of the time is 20 to 40. So you can simply work out 20 to 40. The 40 minus 20, that is turn up to 20. Find the interquartile range. Interquartile range is from here to here. That is how much? 37 minus 25, it's equals to 12. Then what you can understand is using the quartiles, describe the skewness of this data, give a reason for your answer. Now let's check with what is the gap between Q2 minus Q1. Q2 minus Q1 is it's 31 minus 25, it's 6. Then Q3 minus Q2. Q3 minus Q2. Q3 minus Q2 is 38 minus 31. 38 minus 31. Yeah, sorry, 37. Sorry, 37 minus 31. That one also 6. Therefore, the gap is same. Therefore, you can say Q2 minus Q1 is similar to Q3 minus Q2. Then what you can say, but it's a symmetric. We already learned this fact over here. From the, if the gap between these quartiles are similar, we can call it a symmetric. If this gap is narrow, it's positive skewed. If this gap is negative, it's negatively skewed. That's how we already work out with this. We'll work out further. Okay, Chetna believes that the house price will be higher if the time to travel to work is shorter. Right. She asked a random sample of these workers for the house price in pounds, where X is the measured in thousands, and obtain the following statistics. Calculate the product moment correlation coefficient. So I'll just do it here. Gamma value you can calculate by SXY divided by square root of SXX into SYY. So SXY it's given. So over here it's T and what do you call that? X. So it should be actually this should be XXT. SXT is 10 divided by SXX. SXX is 5,514 into 1,145.6. Okay. So if you will work out and see, I do. Yeah. Then put a 10 divided by the square root of 5,514 times of 1,145.6. So it shows you a pretty small answer, 0.004. Okay, state a giving reason whether or not your correlation coefficient supports Chetna's belief. So you can say it is a very small value. So you can say gamma is close to 0. Therefore, we cannot see a clear relationship between the price and the distance to work. Therefore, Chetna's belief is not valid. Not valid. That's what we need to write with this question. Right. Adam and Berry are the part of a group of office workers, and they have both moved their house. Right. Adam's time to travel to work changes from 32 to 36. It increases by 4 units per day. It increases by 4 units. Battery's time to travel to work changes from 38 to 50. Here it increases by 4 units, and here it increases by 20 units per day. Outliers are defined as values are more than 15 times of the interquartile range above the upper quartile. Showing all necessary workings of the calculation determine how the box plot time travel to work will change and draw the new box plot. Right. So what you can get here is you can see it's a 3-mark question. Right. Now let's see how to do this part of it. Right. Then when you come up to this question, see whether the new information. Now look, you can see when you're working out with this question number F, we can work out the lower boundary. So upper boundary, we'll calculate the upper boundary. Upper boundary is the first quartile is, sorry, the third quartile is 37 per day. 37 minus, sorry, 37 plus 1.5 times of Q3 minus Q1. Q1 is 25 per day. So this value is this 37 plus 1.5 times of 37 minus 25. So that value is 55 per day. Now you can see, now there is another value added for that. This 58 is an outlier. 58 is an outlier, and there is another 62 outliers already there. These figures are already here in this set. Therefore, what we can get here is that other one is 36. It's 32 turn up to 36. It does not make a big difference over here today, because you know that it's not an outlier for this question, and as well as it's already there in the 32 and 36 are already there within the box plot in between second quartile to third quartile. It does not make a much change over here. Only the effect comes with this information turn up into an outlier for this question. So how to draw this one is, we can just do like this. I just go to another diagram. I think it's here. Sorry, here the lower boundary is 1 second, 20 and 40. Okay, over here you can mark this information today. The boundaries are 20 and 40. I will just mark them. 20 and 40. The first quartile is, we already knew that it's 25. 25, and the median, the third quartile was 37. And the median was, what is this one? So I just, median over here was 30, 31. 31, median was 31. Then it came like this. You can draw the box plot in this way. So, box plot, sorry, I just, without the annotation, we have to do it. So over here, sorry. It's here, 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 and you can just draw like this. Here, and outliers are there. The first outlier is 58, because that is came from the new one. Another one is 62 is there. It's another outlier over here. Those are the two facts where we can understand with this diagram. Right?
Okay, sir.
At a school athletic day, the distance in meters achieved by students in a long jump are modeled by a normal distribution with mean 3.3 and standard deviation of 6. Then we can start the question over here. X is the distance, the distance where they jump the long, what we call where they having it that long jump event today. So this distance you travel is having a normal distribution of 3.3, 0.6 squared. Find the estimated proportion of the students who jump less than 2.5. We need to find probability of X is less than 2.5. So the first step is we need to make them into standard normal. When you make them into standard normal, the variable turn up to Z is less than 2.5, subtract the mean value, divide by the standard deviation. With this, you can get the answer. He said, sorry, I'll just do it here. Yeah, then it's turn up to probability of Z is less than, it's turn up to 2.5 minus 3.3 divided by 0.6. It's turn up to minus 1.33. We know that we can't read the minus probabilities. Therefore, I just multiply this inequality by negative. Then the side of the inequality changes with this. Then Z is greater than 1.33. You can find it by 1 minus Z is less than 1.33. With this, you can write 1 minus, you can get the 1.33 probability from here. 1.33 is this one, 9082. 9082. So you can get 0.9082. With this, you get the answer as 0.00912. That's the final answer for this question for this one. Right. So this is the proportion. Sorry, the proportion we will get it over here. But then part B. Part B is just like this. Right. The long jump competition consists of 2 jumps. All the students can take part in the first jump, and 40% of who jump the greatest distance in their first jump qualify for the second jump. Find the estimate the minimum distance achieved by them to qualify for the second jump. To qualify for the second jump, the distance you travel, the jump, the amount you put in the jump in the first try should be greater than a certain value. Then this proportion is how much? The highest 40%. That means 40% means 0.4. The probability of obtaining the highest proportion should be 0.4. Right? So we will work out initially. The first step is we need to make them into standard normal. The variable turn up to Z is K minus 3.3 divided by 0.6 is equals to 0.4. We will see from this table. There's one more way we can do it. From this, if you come up with the normal distribution table, there is another part of the table over here. They have the greater region, certain amount of probabilities. But this is a greater region. But there are no more probabilities are there, just only a couple of standard probabilities here. You can see this. So you can write this answer like this. K minus 3.3 divided by 0.6 is equals to, for the greater region, these couple of probabilities are there. 0.2533. With this, you can work out this question. Yeah, so sorry, it went, everything went again. Sorry, I made a mistake. 1 second, we have to just remove this one. Stable. We'll do it from the beginning. Sorry, I made a mistake. So we'll do it. Yes, over here, I'll just quickly do it with the normal distribution of 3.3, 0.6. So the first probability is x is greater than 2.5. So make them into standard normal. Z is greater than 2.5 minus 3.3 divided by 0.6. So this is turned up to probability of Z is greater than, if you just do it, minus 1.33. Z is, sorry, the least 2.5. I just made a mistake. The least 2.5 should be less than minus 1.33. To change the sign, it's turned up to greater. Z is greater than 1.33. So that is 1 minus probability of Z is less than 1.33. That is 1 minus the probability is 0.9082. That is 0. We got this answer 0912. 0912. Then the next part is, if you work out with this, the probability of distance you travel should be greater than a certain value. This should be the highest 40%. 40% means 0.4. Initially, what you need to do is we need to make them into standard normal. Z is greater than K minus 3.3 divided by 0.6 is equals to 0.4. From that table, we've gotten that answer. K minus 3.3 divided by 0.6 is 0.2533. So if you simplify this, you get the answer K. The distance you need to put a jump should be 3.452. If you put a jump up to this extent only, you will qualify for the, if or more than this would be the, that would then only you be qualified for the next level of the competition. Then the next part of it, that is the part B answer. Part B answer. Then part C. Let's see, let's go ahead with the part C. Okay. Then find the estimate of the median distance achieved in the first jump by those who qualify for the second jump. Right. Now let's see. This is coming under the condition like this. they mentioned that find the estimate of the median distance achieved in the first jump by those who qualify for the second jump. It's given that they have qualified for the second jump. That means they have given x is greater than k value, what you gain over here. And honey, what is the distance? Find the estimate of the median distance achieved by this. Honey, what is the distance? They should travel, they should have a jump. I'll just get this value as another figure. I'll just get like m or something. Then they mention it's a median. But if it is a median, what is the probability of having a median? Median should be 0.5. They have given, look at this. Find the estimate of the median distance achieved in the first jump by those who qualify for the second jump. Those who qualify for the second jump is this bit. That means the probability is greater than this. Is given by, you need to find what is the distance you travel to get the median distance. Median means in probability of 0.5, right? Let's work out with this. If you write the conditional probability, x is
how to get 0.5?
Yes, the 0.5 because they mention though find the estimate the median distance. The median means exactly middle.
Okay.
Exactly middle means what should be the probability? Probability should be 0.5. That's how it comes. Okay. Intersection x is greater than k divided by probability of x is greater than k, right, equals to 0.5. Then we know that if you like the median distance should be definitely more than the what do you call that? The boundary line, because then only you will get a qualify for the second jump, and in the second qualification even they are at the highest part. That means obviously this m should be greater than k. Here you can write this probability like this. Divided by, we know this probability. That value we already found that value. X is greater than k value we already know 0.4 equals to 0.5. Then you can say probability of x is greater than m should be 0.2. Then we will make them into standard normal. M minus 3.3 divided by 0.6 should be greater than 0.2. Then greater region 0.2. You can find it from the normal distribution table. I'll work out over here. Greater 0.2 is there, but that is 8416. Greater region standard probabilities are there. So we will work out 0.2 means for the 8416. Then you can write m minus 3.3 divided by 0.6 is 0.8416. Then you can get the value for m. M would be, to work out with this, if you simplify this m become 3.80. 3.80496. From here you can get the answer for m. Right? That is the answer for part C. Let's come to part D. The distance of the second jump is independent of the distance of the first jump, and it's modeled with the same normal distribution. Student who jumps the distance greater than 4.1 in their second jump receive a certificate. At the start of the long jump competition, students selected at random find the probability that the student will receive a certificate. To receive a certificate, what is the condition? To receive a certificate must qualify for second round, and you have to have a jump more than 4.1 in the second jump. Jump more than 4.1 in second round. Qualify for the second round probability, we know it's 0.4 here, because we already found with this one. 0.4 into, we need to find this probability. How to get this probability? Probability of x is greater than 4.1. We have to make them into standard normal. He said is greater than 4.1 minus 3.3 divided by 0.6. That means, if you just work out this part of it is 4.1 minus 3.3 divided by 0.6 is 1.33. Probability of Z is greater than 1.33. This is similar to 1 minus probability of Z is less than 1.33. That is, I think we already gotten that answer. 0.0912. 0912, and the first part is 0.4. So the final answer should be 0.4 into 0.0912. With this, you can get the answer for that. That answer should be 0.03648 would be the final answer for this question. Right. When you come to this question, just make it a little bit smaller. Right. Okay. Start here. The partially completed tree diagram where P and Q are the probabilities given information about Andrew's journey to work in each day. So what are the facts we can fill up with this today? If this is P, simply you can write this value is 1 minus P. If this is 0.4, this should be 0.6. Then addition of this tree should be 1. Therefore, this should be 1 minus addition of this two. Should be 1 minus Q plus 0.15, because you know that addition of this tree should be 1. So it's turned up to 0.85 minus Q. If you simplify this, 0.85 minus Q. Okay, let's do this further. Then R represents the event that it's raining. W represents the event that Andrew walks to work. B represents Andrew takes a bus to work. C represents an event Andrew cycles to work. Given that PB means the bicycle, sorry, he's traveling to bike. That means B means this event and this event. Addition of these two events they have given as 0.26. Then part A, this event is P into 0.4 plus this is 1 minus P into 0.15. They have given this value as 0.26. B comes from here and here as well. So it's turned up to 0.4P plus 0.15 minus 0.15P is equals to 0.26. If you add these two together, 0.25P is equals to, if you brought it here, 0.26 minus 0.15. Let's turn up to 0.11. Yeah. 0.11. Therefore, P become 11/25. So now if you want, you can simplify these ones with those probabilities. Just keep it. Later on, we can do this calculation with it. Given that probability of R dash given W is 0.175. Remember that how to do this question. For that, the theory what we need is probability of A given B is probability of A intersection B divided by probability of B. This is the usual format for given condition. I'm using the same context. Here the fact B given here is probability of R dash, not R, given W. Now you may be confusing what do you mean by R dash. That means probability of R dash intersection W divided by probability of W. What is W? W is walks to work. And the first one is R dash W. R dash means what? R dash is this one. It's R dash into W. So they have given this value 0.175. 175. R dash W is this one. That is 1 minus P value you already know. 1 minus 11/25. 1 minus 11 over 25 into Q divided by probability of W. Walks to work. Walks to work is this bit. 11 over 25 into 0.6. This one and this one. Plus 1 minus 11 over 25 into Q. Now let's try to work out with this question. If you simplify, you get the answer. 0.175 is equals to 1 minus 11 over 25 is 14 over 25 cube. 14 over 25 cube divided by, here the value is 11 over 25 into 0.6. That is 33 over 125. 33 over 125 plus this value again, 14 over 25 cube. Then we can cross multiply and simplify. You can just take this into these sides and cross multiply and do this. With this answer, if you simplify further, you can get the answer as Q become 0.1. We'll work out and see. If you cross multiply over here is 0.175 into 33 over 125. It's 0.0642. 0.0462 plus 0.175 into 14 divided by 25. That is 0.098. 0.098 Q is equals to 14 divided by 25. That is 0.56 Q. Then take this Q to this side and simplify. You get the answer Q as 0.1. Now you know these figures. So I'll just do the additions for this question. This is 11 over 25 and this is 14 over 25 and this is 0.1. Q is 0.1. Therefore, this is 0.75. Right. These figures we know, right? Find the probability that Andrew cycles to work. Find the probability that Andrew cycles to work means what are the facts? That is this bit. That is part C is 14 over 25 into cycles to work means this bit. 0.75. 14 over 25 into 0.75. That is 0.42. D is given that Andrew do not cycle to work. Now we'll come up with a conditional probability, not C. But on Friday, find the probability that it was a rainy day. It's a raining day. Right? So we will put the conditional probability, the probability of R intersection C dash divided by probability of C dash. What do you mean by C dash? It not cycles. It's raining and not cycles. Raining and not cycles means addition of these two. This is here, it's raining and not cycles and divide by probability of it's not cycles. That's what you write it with this. Raining and not cycles means this bit. 11 over 25 into 0.6 plus 11 over 25 into 0.4 divided by not cycles. But the not cycles means this branch, this branch, this branch, and this branch. So you can see, rather than adding all of them together for this one, you know that if you add all these probabilities at once, like this is the theory we use, that means not cycle means this one, this one, this one, this one all together, except this branch. We know that if you add them all together, that is equals to 1. It's equals to 1. So out of 1, if you remove this part of it, you can get the rest of the probabilities. That's a simplification that is we do for the convenience of the simplification. 0.75. With this, you can get the final answer for this. We'll just do it. Fraction. The fraction 11 over 25 into 0.6 plus 11/25 into 0.4 divided by 1 minus divided by 25. That answer is 22/29. This answer becomes 3/29. This is the final answer for this question. Okay, that's how we do it. Right. Thomas is studying the relationship between the temperature of hours of sunshine. So we just highlight these facts. Yeah, the hours of temperature and the between the temperature and the hours of sunshine in Seaform. Right. The first question is, we need to calculate SSS. So SSS, we can just simply say summation of S squared minus summation of S whole thing squared divided by number of information. They did it for 9 towns, 9 cities. So if you can get this answer, 44.22 minus 15 squared divided by 9, you obtain the answer as 19.2. This answer is 19.2. That's the answer for this one. Thomas calculated the product moment correlation coefficient between S and T is 0.832, correct to 3 significant figures. Right. Then state giving reason whether or not this correlation coefficient supports the use of linear regression model. Yeah, obviously it has a strong relationship. Therefore, you can go ahead with the linear model, support with the linear model. So you can write, since gamma shows a strong relationship, we can use a regression model. That's the answer for this question. Right. State giving reason why the hours of sunshine would be experimentally variable in the linear regression model between the midday temperature and the hours of sunshine. What do you mean by the experimentally variable? Experimentally variable means like the independent variable. So you know that depends on the number hours of sunshine, only the temperature changes. Therefore, hours of sunshine would be the independent variable or the experimentary variable. That's the fact we need to write it today. So answer C, we write it. Depends on the number of hours of sunshine, the temperature changes. Therefore, this is the independent variable or experimentary variable. That's a fact we need to write the answer for this question. Right. Okay. Because you know that number of the amount of the temperature, the sunshine does not vary. Amount of the sunshine only, the temperature varies. So there is a reason for me to write the answer in this format. Right. Okay. Find sum SST. So this is yeah. Let's go ahead with this. The SST. I'll do it here. It's easier for me to do it. So yeah, SST is the summation of ST. Summation of ST. SST, summation of ST into, then there's a problem. How to find SST? So the usual format where we know is this bit, summation of SC into summation of T divided by N. But we don't know this summation of ST, we don't know. Summation of SV, S and summation of T, no, but without knowing this part of it, we can't do it. Then we can go with the alternative method to do this question. We know the product moment correlation coefficient is given in the question. Here, the product moment correlation coefficient is given here, this bit. Then you can say gamma 0.832 is equals to SST divided by square root of SSS. We already found it as 19.2 into STT. It's given over here 10.89. By simplifying this, you can get SST. So we will work out and see 0.832 multiplied by the square root of this denominator, 19.2 into 10.89. So with this, you get the answer 12.03. This answer is 12.03. That we have got a little bit of a tricky question to work out with this. It's kind of a little bit extraordinary than the method where we used today. Calculate a suitable regression line to model the relationship between midday temperature hours of the sunshine today. So you know that over here, I'll just use this. Yeah, right. Then the equation, look at this. So when you're working on this, we need for the gradient. What is the gradient formula? That is Sxy divided by Sxx. This is an independent variable. According to this relationship, this is X variable is what we call that number of hours. SST divided by S independent variable is the SSS. The temperature is the dependent variable, that is a Y variable, and X variable is S. So we need to understand it clearly. SST we already found it as 12.03 divided by SSS. SSS we already found it 19.2. So we have to identify this variable is quite important. Remember, here the X variable is S and Y variable is T, because depends on the number of hours of sunshine, only the temperature changes. Therefore, this is the X variable, independent variable, and this is the Y variable over here. So we will get this answer. But if you do this, its answer is 0.626, 6.062, yeah, 62, somewhere like this. Then we can get the A value. But A value is by bar. Y bar is T bar minus B S bar, right? T by summation of T. The summation of T is 127 divided by 9 minus B is this bit, 0.6262 into S bar. S bar is summation of S divided by number of information. With this, you get the answer for A. You get the answer for A would be this. 1 second. Letter A comes with 13.1 today. 13.1. Then you can write the equation T is equals to 13.1 plus 0.6262 S. That's the final regression line today. Then that is the answer for E, F. Then calculate the standard deviation of S today. When you're working out the standard deviation of S, that should be sigma S, sigma S. Initially, we can find sigma squared S by summation of S squared divided by N minus summation of S divided by N whole thing squared. It's a 1 mark question. Anyway, let's see whether can you find some fact with this. The summation of S squared. Summation of S squared. Do you know? Yeah, we know this value. 44.22 divided by 9 minus summation of S is 15 divided by 9 whole thing squared. With this information, you can get the sigma squared S. 1 point. So you can get the answer as this bit. That is 2.13. 2.13. Therefore, sigma would be the square root of 2.13. That is 1.46. 1.46 would be the answer for this. That is the standard deviation for this F. Tom uses this model to estimate the midday temperature of Cypron of the day of October with 5 hours sunshine. State the value for Thomas's estimate. So this is pretty simple. You can just put 5 into this equation today. So you can write T equals to 13.1 plus 0.6262 into 5. With this, you get the answer. Temperature over here is 16.2 and H. Given that the value S are all in two standard deviation of the mean, comment your reason on the reliability of this estimate. Then put yes. So what you can understand is put this information is within the range. Actually, this answer is within the range. Given that the value of S are within two standard deviation of the mean, that is correct. Come and give you a reason, the reliability of the estimate. So in this case, you can see when you're working out with this, it comes with 16.2. Right. Make up when you're working out with this, we need to be a little bit vigilant with this. This answer. Let me see this answer today. Over here, it's a 2-mark question today. Right. Here, what is the mean value for S today? You get it. S bar is 15 divided by 9 today. So the mean value for S is 1.66 with the 1.67 obviously. Then if you get from S 1.67 and if you get 2 standard deviation to this side, but because they mentioned that value should be fall into 2 standard deviation, we already found the 2 standard deviation for this side. 2 times of 1.46 and 2 times of 1.46 to this side. If you work out plus 2 into 1.46 is 4.58. And to the negative side, it's not that much appropriate because you know that here, this region is, they mentioned that the value should be fall within the 2 standard deviation from mean today. The mean value is 1.67. If you go to the 2 standard deviation of the greater side is 4.58. But here the value is how much? It's pretty large. This value is pretty large. That means this value won't be much reasonable as an answer. So you can say the answer does not fall into 2 standard deviation from mean. Therefore, it's not reasonable. It's not reasonable. That's a fact we need to understand with this question. Okay. A biased coin has a probability of 0.4 showing the head. So over here, the probability of getting head is 0.4. Therefore, the tail is 0.6. That's a fact we have given. In an experiment, the coin is spun until the head appears. Until the head appears. If the head has not appeared after 4 spins, the coin is not spun again. The random variable x represents the number of times the coin is spun. For example, x equals to 3 means if the 2 spins do not show the head, but 3rd spin does shows a head, the coin would not be spun for the 4th time since the coin is already shown in the head. Show that probability of x equals to 3 is this big. But what you can see here is 3 means first 2 times you get 2 spins do not show head. So the first 2 times is head. Head, and 3rd time only you get a head. That's what you mean by x equals to 3. That means x means the number of times you need to spin this to get a head, right? That means x equals to 3 means first 3 times you didn't get a head and 3rd time only you get a head. That means it's 0.6 into 0.6 into 0.4, right? So you can get this answer. This is pretty simple. You can get the 144. That's the point you need to understand with this. The table given some values for the probability distribution x. 1 means from the first time itself you get a head. From the first time itself you get a head. That means it should be 0.4. This is pretty simple. You can get this answer. Then how to get 4? This is simple. That means first 3 times how to get the 4 over here is what happened here is For just 1 sec. So write down the value for this bit is 1, x equals to 4. X equals to 4 means for the first 3 times you didn't get a head. First 3 times you didn't get a head, and only the fourth time only you get a head. So you can write this is B2. B2 is tail, 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 head. That means put 0.6 into 0.6 into 0.6 into 0.4. That's a fact we need to understand with this. So that value become then yes. So if you just do this and see 0.6 to the power 3 times of 0.4, it's turn up to 0. Yeah. 0. You can, other than that, it's just an easier method than this, right? You can do it in this way also. So simply there are a lot of combination comes in this branch, but rather than that, there's a one easier method. What is that easier method for this? Is just like this. We know that this is the entire experiment. This is the entire experiment. If you add them together, what would be the answer for this? You know that if you add them all together, that should be equal to 1. So out of 1, if you remove the rest of it, you should get this probability. Because the first method which I'm using is you have to use a couple of other combinations as well. I think this method is quite easy. So you should get the answer. 1 minus of this could be 0.216. 216. With this, you can get the answer over here. 0.216. This is the quite easier method to do this question, right? Okay. Then find EX. See, EX simply you can get 1 into EX. You can write 1 into 0.4 plus 2 into 0.24 plus 3 into 0.144 plus 4 into 0.216. Those are the facts. So we get the answer very easily. EX become 2.176. 2.176 would be the EX. Then var X. To find var X, initially we need to find EX squared. That is 1 squared into 0.4 plus 2 squared into 0.24 plus 3 squared into 0.144 plus 4 squared into 0.216. This answer become then 6.112, sorry. Then variance of X become EX squared minus EX whole thing squared. The X squared is 6.112 minus EX, we already found it as 2.176 squared. With this, you can get the variance of X as 1.377. You can get this answer in this way. That's a way of getting the answer up to that extent, right? Then now the next part, when you come to the next part, only another kind of confusion comes to this question. A random variable H represents the number of heads obtained when the coin is spun in this experiment. The random variable H represents the number of heads obtained when the coin is spun in the experiment. Explain why H can only take the value 0 or 1 and find the probability distribution of H. Right. So you can say right. Now read the question clearly. Right. The random variable H represents the number of heads obtained when the coin is spun in this experiment. Yeah. Then how do you get this answer? Right. This is the way. Right. So when you're working out with this, you can get only 0 or 1. The condition here is just like this. Either like the question is explain why h can only take the value of 0 or 1. So you know that either you will get a head or you don't get a head. Whatever the time, you don't get a head. So if you work out with head, how do you find the probability of head getting to that? So you can write the answer for this question is like this. So you can write, if you get the head at first time, if you get a head at the first time, if you get at the first time, you get 1, or otherwise you get 0. That means when you get a head, you count it as 1, and if you don't get a head, you count it as 0. Then the events available here is only these two. The probability of heads is equals to 0, or the probability of head is getting as 1. That is the answer for this question, right? Yes. Now, if I just come up with this answer, this is what. Look at this. You have to read this question very carefully. The random variable h represents the number of heads obtained when the coin is spun in this experiment. Right. Explain why h can only take the value of 0 and 1 in the find the probability distribution of h. That means when you're doing this, h means number of heads you get it. So you know that, like, when you get a head at this experiment, you stop the process. When you get a head, you stop the process. Therefore, what is the maximum number of heads you can obtain in this experiment is how much? Can be only 1. Is that clear?
Yes, sir.
Yeah. So in this case, this is the way. So you can write, if this answer is not clear with you, you can explain like this today. When you get the first head, you stop the process. You stop the process. Therefore, maximum value for h would be how much? Would be only 1. Only 1. Therefore, we can get probability of h equals to 1 or probability of h equals to 0, where you don't get any hits. So you can see the maximum time you repeat this experiment is how much? After 4 spins, you don't do this experiment again. Then for all 4 times, if you don't get any head, then this h should be how much? Then the h should be 0. So what the probability of getting all 4 times you don't get a h? Head. It is 0.6 to the power 4. First time also tail, second time also tail, third time also tail, fourth time also tail. After that, we stop the process. Therefore, the maximum, so after doing for the 4 time even, if you don't get this value would be the probability of h equals to 0. So if you just work out with this, it should be 0.1296. Then all other elements, the first time, second time, third time, up to 4th time, if you do it, you get the rest of it, whatever the time, you get a h equals to 1. So how to get this probability? You can draw the tree diagram and do it, but you know that only 2 events are h equals to 1 or h equals to 0. Therefore, this value you can get 1 minus 0.1296, or you can do it with you can draw long, what do you call that, tree diagram, and you can do it, but it's rather than that, doing this is much easier, because you know that there are only 2 outcomes we can see, because in the experiment even they mention only 2 outcomes. If 0 is this bit, 1 should be the 1 minus this answer. 1296. So you can work out with this. This answer should be 0.8704. That's the fact we need to understand with this question. Okay, right. Then part F. You can see, write down the value for x equals to 3 and h equals to 0. That means, Pute, after doing for 3 times, and you don't get a h, Pute. They mention x equals to 3 means you get a head at 3, and like you know that after getting like 3 trials and you don't get a head. That means, Pute, you know that obviously when you trial it for 3 times, there is a probability, there's a chance of getting a head over here. Therefore, this probability, it cannot be happen because you know that anyway, after 3 trials, you can get a head. There's a probability of getting a head over here. Therefore, like whatever the situation, after trying for 3 times, you get a head. Therefore, this probability would be 0. X equals to 3 and h equals to 0. This value should be 0. The reason is that obviously we know that after 3 trials, you can get a head itself, right? Then the next one, part 2 is probability of x equals to 4 and h equals to 0. Yes. How do you get that answer, Pute? That means, Pute, if you trial it for 4 times, but still you don't get a hit, that is this bit. 1296, because you know that means all of them you should get a head, tail, 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 tail. But here, after trialing for 3 times, we have a chance of getting it. That's a fact we need to understand with this distribution. Right? Okay. That's the answer for F1 and 2. Okay. Then we know that they have given the random variable s equals to x plus h, right? The possible elements of x is 1, 2, 3, and 4. The possible element for h would be 0 and 1. Therefore, these are the possible values for getting for x plus h. That is 1 with 0 is 1, 1 with 1 is 2, 0 with 2 is 2, 2 with 1 is 3, 2 with 0 with 3 is 3, this is 4, and like it goes on. Therefore, let's go ahead with this. Therefore, the distribution for S would be, you have these values. 1, 2, 3, 4, and 5. Right. Let's go ahead with this. Now you can understand that simply Pute, okay, all these elements can be like this way. You know that this is a situation. From the first time, 0 plus 1, that means like you are getting this kind of situation. I mean, this elements indicates you that you don't get a head at you will get a head at the first time, and what do you call that? This element is you are throwing for 1 times and you get a head, and first time you don't get a head. Can it? You get you have to trial for 1 time to get a head. Then here you don't get a head. There is no such elements you can see. Anyway, you know that if you want to put a 1 time, if like at the first time you get a head, means there is no way of getting no heads at the first chance. Therefore, this probability should be 0. Then we know that the second situation is just like this. They mentioned that the probability of getting 2. Actually, these ones are a little bit of a confusing questions. These are like a little bit of advanced statistics parts are there in this question today, because like you have to mentally you have to work out this question and to get this answer. So what you need to get here is here they mention this one as this way. Like X means the number of trials you need to get ahead. The number of trials you need to get head is 2, and as well as at the first time even you get this probability for this. So this answer should be this way. 0.24 plus 0.16 from the probability distributions. This is turned up to 0.4. Then 3 would be the same answer with this 0.4. Then 3 should be the same answer of the accumulation of 0.24. And 4 should be, we know that already found the value for 4. It's here at this element 0.1296, and the last probability you can find it by 1 minus addition of all these 4 together. That answer gives you 0.0864. That's a way of getting the probability distribution for this.